Okay, today we're going to start some new ideas that really underlie a lot of those video games you've been playing. We'll talk more about that in a moment. Just to get started, though, we haven't plotted points in a while, so I'm going to ask you to pause the video and imagine, plotting these points. You could take a piece of graph paper right now or just a regular piece of paper and just kind of plot the points and create a rectangle with six units on one side. And over here, you're going to plot the 2 points and create a square with those 2 points and obviously two others that you're going to put in. Down below, I'd like you to leave the calculator aside for right now. I'm not saying you can't use it in today's lesson, but a lot of people will go and do this kind of math in their head, not with a calculator, and they're making mistakes. So I just want you to do a little practice of your positive and negatives because we have not been working with those in geometry. We're not talking about negative lengths on a prism or a negative height on a cone. So what I'd like you to do is to try these problems, just write your answers down to make sure that we just get our brain kind of back focused on some negatives. So give that a go and come back in a second when you're ready to check. Okay, so first we had to start with plotting the points. So remember that when you plot a point, you start at the origin. The first number goes in the x direction. So that's left, right. If it's negative, so -3, you go to the left. If that had been a +3, you would go to the right. So the first point we're plotting is going to be -3 in the x direction, +3 in the y direction, and that's why B is right here. That point's coordinates is -3, 3. The other point, you would start at the origin. The first number says to go left or right. Because it's a negative, you're going to go left in the x direction, 3, and there's A. You had to add 2 points to make the length of the rectangle be 6. So since there was already 3 here, you only really had one choice, but to go out to the right because the graph paper would run off, going to the left. So there's a rectangle that meets the requirements. Over here to graph G, you would have gone +5 in the x direction and not gone up or down, so that's where G should be. Go back to the origin. You're not going to go left or right. You're going to go 0 in the x direction and then up 5. Just want to warn you, plotting points with 0 coordinates in either an x or y, a lot of kids make a mistake and put them in the wrong spot. And then you had to make a square with 5. So that would be the only way you would get a square with these 2 points, G and H, being quarter points, which in math is called vertices. So just remember that when you're adding a positive and negative, you actually subtract the absolute values, which would give you 2. And then notice the 5 is more negative, so you would have -2. Same thing over here. 9 minus 7 is 2, and it's going to be negative because the -9 has more weight. But when you come down here, you're adding 2 negatives. So you would take the -8 and add the -6. So 8 plus 6 is 14, and it would stay negative. This one's pretty obvious with a -6. Adding 2 negatives, you add and keep the sign. Number 7, adding 1 of each, you would subtract and keep the sign of the heavier. And number 10, 1 of each, you would subtract to get the 6, and it would be negative because of the 8 having more weight and being negative. And then same thing here, 3 take away the 1 would be 2, and it's going to be positive because of the 3. Remember, you can use the calculator. You shouldn't have to be honest. But just be careful if you're doing it in your head that you remember those basic positive and negative addition rules. So the unit that we're starting is called transformations. And there are basically 4. There are 3 that are called rigid, 1 that isn't. We'll talk more about that later. And there's 3 of them. They're kind of all depicted on the slide here. So the first one we're going to do is translations. And translation is the word slide, where your shape just kind of moves to another place. It doesn't turn. It doesn't change its orientation or its shape or its size. And it just kind of moves to the left and down, or maybe it will move to the right and up, but it's like it's sliding on ice. Today we're going to talk about translations. The next thing we would talk about is a reflection, where it is going to, you're going to notice its orientation is different. It's like it's looking in a mirror and it flips, and you can kind of see a real world picture over here of the reflection of that mountain. The last one is going to be a rotation. That's a spin. If you play basketball, think of planting your pivot foot and spinning around on that pivot foot. That's called a rotation. All of these are sort of the basis for animation and video games, things moving around on the screen. So these are sort of the basic underlying ideas when you program one of those games or animation so that things are moving. These are the basic ideas behind that. So just to give you a little bit of vocab, a transformation is an operation that maps an original figure, a geometric figure, and that original figure that you start with is called the pre-image, before image. And it's going to map it, it's going to move it onto a new figure called the image. We use a capital letter to represent the pre-image. And when we move it to a different place, we'll use that same letter and put this little marker here. It's called a prime. So you can tell that this is where you started because it's missing the prime. And down here, this one is where you ended because it has the prime. Now, a translation, which is the transformation we're talking about today, is going to slide a figure from one position to the other without turning it. So if you look at this kind of weird puzzle piece here, and it starts in this position and it moves here, it moved one to the right and down one. That's called a translation. We're not going to talk about a diagonal slide. In order to move things, we're going to move them horizontally and vertically. So let's start with some discussion of what a translation is. So basically, each one of these corner points, which are called vertices, they're a vertex, is going to move a certain number of units left or right, and then a certain number of units up or down. And they're all going to move with that same left-right motion so that the shape stays rigid, stays the same size. So if we look at this one up here, this point A is the pre-image corner, and notice the A prime down here is where this shape is going to land. So we start with the blue and we end up with a green. To get this guy from here to here, and you can't move diagonal, we're always going to kind of do left, right first because of the x-axis is left, right. You're going to have to move that A 1 to the left, 2 to the left, 3 to the left. So if A moved 3 blocks to the left, it would line up here, and then it would have to move 2 down. So 3 to the left and 2 down would be called a translation. Now, if you go to point B and you move him 1, 2, 3 to the left and 2 down, notice there's B prime. And the same thing with C, 3 to the left and 2 down. And you will get this new green image, and it's the same shape and the same size. Because these two triangles have the same shape and size, the word in math is called congruent. They stay congruent. And when you do a translation, your shape should look identical to the one you started with. And if not, you've miscounted, basically. Now I'm going to show you this right here. This is called, translation notation. Big fancy word. And basically what it does is it allows you to sort of shorthand moving 3 to the left and 2 down becomes this notation. So if you're talking left, right, you're going to connect it to the x variable. So you're going 3 to the left, you would take the x coordinate, whatever it was, and take away 3. So the x coordinate here, notice, is 2. If you take away 3, you get -1, and notice the x coordinate of your new A prime is a -1. Now the y coordinate is going up or down, so remember we were going 2 down. So if you take the y coordinate, which in this case would be 3 on the A, and you take away 2, that would give you a 1, and notice that the new y coordinate would be 1. So this translation notation allows you to change the coordinates without even plotting the points. They're talking over here about this A prime. So pre-image doesn't have it, and the image after you move it does, and I have no idea why they repeated B. I have no idea. Whoops, I just moved it. Let me put it back. Okay, so let's just take a look at an example of a translation. So I'm going to do this one 2 ways. I'm going to do it on the graph paper, and then I'm going to talk about how would you do it if you didn't have the graph paper. So they plotted the points. Remember, -3, 4 would be J, +1, 3 would be K, and -4, 1 would be L, and there's the triangle, and they want to move it 2 units to the right, and 5 units down. So you would take each vertex, each corner point, and you would move each one 2 to the right and 5 down, and there's K prime, 2 to the right and 5 down, and there's J prime, and 2 to the right and 5 down, and there's L prime. Connect them, and there's your image, pre-image and image. So when you have graph paper, it's a counting exercise. But what if you didn't have the graph paper? Remember that when you're talking about left, right, that's in the X direction, same as the X axis. So if you're talking to the right, that's positive. So the translation notation for 2 to the right would be X plus 2. When you're talking 5 down, that's in the Y direction. Y minus 5 would be that notation. And this is how easy you can do it without graph paper. Once you have this notation, just take the X coordinate of the pre-image, -3, add 2, and you get -1, and there's the X coordinate of J prime. Take the Y, 4, take -5, and -1 would be the Y coordinate of J prime. And if you come up here, look, -1, -1, there's J prime. So you can get these coordinates without having graph paper. And to be honest, that's what a computer programmer does. They just put the translation notation in, how something's going to move into the computer in code, and then the computer will shift Mario or something like that around the screen. So that's how we can do it 2 different ways. So we're going to practice. So on this one, I'm going to do it the reverse this time. Instead of graphing it, I'm going to use the translation notation to get the new coordinates, and then I'll show you the graph as well. So I have a triangle. These are the 3 vertices, the corner points, and I want to move this triangle, which if I drew it and connected those points, the triangle is going to be the pre-image, and then I'm going to move that triangle 4 units to the left and 3 units up. So the first thing we're going to do is connect that to the translation notation. So remember that left, right gets connected to X, and up, down gets connected to Y. So if we're talking 4 to the left, you're going to take your X coordinate, and left would be subtract 4. If you're talking about up, that would be positive, so you're going to take your Y and add 3. And this is the translation notation. I'm going to take the coordinate, X coordinate 4, and 4 minus 4 would give me 0. Put in the Y, and -3 plus 3 would also give me 0. So the new A prime would be positioned at the origin, 0, 0. Take your X coordinate, 0 minus 4 is -4. Take your Y coordinate, 2 plus 3 gives you 5. And your B prime is going to be at -4, 5 up here. And then take 5 as your X coordinate, subtract 4. Your new C prime X would be 1. Put in the 1 for Y, add 3, and there would be your new. So without even graphing it, this would be the corner points of your pre-image, and these would be the corner points of your image after a translation of 4 units to the left and 3 units up. Let me just show you the picture that would go along with that. So the original is the green. So these are those parts. So if you looked at, for instance, 4, -3, if you looked at 0, 2, if you looked at 5, 1, you would get this green triangle. And I just want you to see, remember, we came up with these points. So do you see the 0, 0? Do you see the -4, 5? And do you see the 1, 4? And look, let's just take B, and let's move B 4 to the left, 1, 2, 3, 4, and 3 up, and there's B prime. So there's two ways to do a translation. You can graph it and find the coordinates after you graph it, or you can find the coordinates using this translation notation and then graph it after if you need to. Here is just another example where they are showing you how to use that translation notation. So these are the original points, X, Y, and Z, that they're giving you. And then they want you to translate 2 to the left. So that's X, minus 2. Oh, by the way, that's the same thing as adding a -2. If you change it. And then they want it to go 1 up, which would be in the y direction, y plus 1. So they're just taking the -1 and adding -1 to get -3. They're taking the -2, which is the y coordinate, plus 1 and getting -1. And they're using this translation notation to get the 3 new points of this triangle after it's translated 2 units to the left and 1 unit up. Remember, this example is done if you need to go back to it, and there will be a filled in notes page as well to refer to. Okay, so let's try that on your own. What I'd like you to do right now is I want you to pause the video, and I want you to take the quadrilateral, which is a 4-sided figure, A, B, C, D. These are the 4 corner points called vertices. And I want you to find the coordinates of A prime, B prime, C prime, and D prime after you translate this guy 4 to the right and 2 units down. The first thing you're going to do here is try to write the translation notation for 4 units right would go in the red, and 2 units down would go in the blue, and then you're going to use that notation to get the new points. What I'd like you to do right now is pause the video and try to do that on your own, and when you have some kind of work done, come back and let's see how you did. Okay, so 4 units right is in the x direction. So did you write x plus 4? You're going to take your x coordinate and add 4, and that will shift it 4 to the right. Down would be in the y direction, and down means negative. So y minus 2, you're going to take your y coordinate and subtract 2, and that will shift the figure 2 down. So if I take the 0 for the x and add 4, I'll have my new x coordinate. And if I take the 0 for the y and subtract 2, I'll have my new coordinate. So that's kind of the math I'm doing. And here is my A prime, which would be 4, -2. So let me just uncover these first, and then we'll see where that all came from. So the first number is the x coordinate that we started with. And then this idea is the adding 4. So 0 plus 4 is 4. 2 plus 4 is 6. 3 plus 4 is 7. And 0 plus 4 is 4. Now, when I went to do the y coordinates, I took the y coordinates, that's where the 0, 0, 4, 4 came from, and I subtracted 2 to shift that point 2 down. So 0 minus 2 is -2, 0 minus 2 is -2, 4 minus 2 is 2, and 4 minus 2 is 2. And this would be that new quadrilateral, which is a 4-sided figure. It would, after it moves 2 units to the right and 2 units down. So here's just giving you a little bit idea more like what I mean by the video game. So, there's some figure and you shift it. So here is a computer image, and it's being translated to create the illusion of movement, kind of like if you ever did one of those flip books when you were a kid. So they're going to take this little cat, leopard looking thing, and they're going to move it, and it moves from A to B, and they're trying to ask you, what was the translation notation to get his paw to move from here to here. So just notice that it started at an x of 3 and it landed at an x of 2. To go from 3 to 2, you subtracted 1. So in the x direction, it moved 1 to the left from 3 to 2. And that's what you're seeing right here. The cat's paw also dropped. It started at a y of 3 and it ended at a y of 1. So it moved down 2, and there's the translation notation. So the cat basically moved 1 to the left and 2 down, 1 block to the left and 2 units down. So now it's your turn to give it a go. Can you come up with a translation to move the cat that's on the left to the cat on the right? Pause your video and see what you did. So he went from 1 to 2, so that would be a translation in the x direction of x plus 1. And he went down 4 from 5 to 1, so that would be y minus 4, and that is the translation notation. So the cat went 1 to the right and 4 down, and that's where his paw ended up right there. Okay, one more time here to see how we're doing. I'm going to ask you to do both of these problems. If you have graph paper, you'd want, you can do it on there. Obviously, with the translation, you can do these without by finding the translation notation. So I'm going to ask you to pause it, and you're going to start with a triangle X, Y, Z in both cases. And in this one, you're going to move it 3 units to the right and 4 units up. And this one, you're going to take the same original, go back to where you started, and you're going to move it 2 units to the left and 3 units down. So pause the video and see if you can do that on the graph paper. And again, if you don't have graph paper, you could just write the coordinates and check them against the new coordinates once I show you the answer. Okay, let's see how you did. So the original guy here is the green one. They've kind of shifted the graph paper here, the origin. That's why it looks a little different. But here is the original. And remember, we wanted to shift this one 3 units to the right and 4 units up. So right here, I'm going to uncover the coordinates, and you can see kind of where the image ended up. So when you're doing it on graph paper, just to remind you, you can simply count each corner point and move it 1, 2, 3, and then 1, 2, 3, 4 to get the new corner point. And you do that 3 and up 4 and 3 and up 4 with every corner. The other way to do it is to realize, what does it mean to go 3 to the right? Well, that's the X direction. You're going to take your X coordinate and add 3. What does it mean to go 4 up? Well, that's your Y direction, 4 up. So it's Y plus 4. And then you basically take every X and add 3. And that's where these came from. And you take every Y, the -4, the -1, and the -2, and you add 4. And that's where these came from. So there are 2 ways to do it, graph paper or to use the translation notation. And just if you take a look over here, each point went 2 to the left and 3 down. 2 to the left is taking your X coordinate -2. 3 down is taking your Y coordinate -3. So if you take the X of -4 minus 2, you're going to get -6. If you take the X of -3 minus 2, you're going to get -5. And if you take the 2 minus 2, you're going to get 0. So you can go right to these points actually without graphing. Then you go back to your Y's and you take a -4 minus 3, and that's where the -7 came from. -1 minus 3 gives you a -4, and a -2 minus 3 gives you a -5. And if you look up here, you could have done it by, the graph paper. There's this 0, -5, which is your Z prime. If you go -6 and down 7, there's your X prime. And if you go -5 and down 4, there's your Y prime. 2 different ways to do a translation. Okay, so I have 2 more to finish off today. So I'm going to pause the video, or you're going to in a second. The first one, number 3, is there's a baseball at the right, was filmed using a stop motion animation, so it appears to be thrown in the air. Use translation notation to describe the transformation from points A to B. So can you come up with the translation notation, and can you say in words, how did the ball move from A to B? The second one I'd like you to do is, we've got a quadrilateral, that's a 4-sided figure. These are its original points in the pre-image, and they want you to find the vertices in the image after you move it 4 units to the right and 5 units down. So you're going to give the translation notation, and you're going to move every point using that to see where it lands. Pause your video, and let's see how you do in about a minute. Okay, so how did the baseball move from A to B? It moved in the X direction to the right. It moved in the Y direction up. So if we were talking about words, it moved right 2 units, and it moved up 1, 2, 3, 4, 5. So 2 to the right and 5 up. Now, translation notation, left, right, this is your X. To the right is positive, so you're going to take every X coordinate and add 2. Up in the Y direction, and it's positive, so it would be Y plus 5. So now in this guy, 4 units to the right, remember that left, right is x, and to the right would be positive, so x plus 4. 5 units down, down is y direction, and down is negative, so y minus 5. So now it just becomes kind of an arithmetic. You're going to take that 1 and add 4 to get your new x coordinate of d prime. You're going to take that 0 and subtract 5. And that's why we did the warm-ups, by the way. It's okay to use a calculator, but many of you hopefully are just going to be doing these in your head. We're going to take the negative 2 and add 4. And we're going to take the negative 2 here and subtract 5. And negative 2 minus 5 is going to give us negative 7. 2 plus 4 is 6, and 4 minus 5 is negative 1. 6 plus 4 is 10, and negative 3 minus 5 is negative 8. And this is kind of what we use again in computer programming or animation to tell a computer how to move different figures around the screen. So our first guide today is called a translation. It's a slide, like you're pushing something almost on ice. They're used on video games, and there's really 2 ways to do it. You can do it by moving a picture on graph paper, certain number of units left, right, certain number of units up, down. But the other way to do it is using translation notation and just kind of tying the number in what direction it's going to the appropriate coordinate. So something like x plus 4 would mean moving it 4 units to the right, comma y minus 1 means moving it the y coordinate at that whole point 1 unit down. So today we've started doing some fancy animation ideas and computer gaming ideas, what's behind a lot of that, and it's called translation. We'll be doing more in the future to move figures in different ways, but today they're basically just sliding. Have a great day, everybody.